Yeah, ah, yeah, yeah. Hi, it's been a minute. Sorry for the delay. I've been fighting my microphone stand. The boom arm keeps pulling the microphone up and away from me, which is, not ideal. So, hi. Good morning, yeah. One second. Sorry, I'm also kind of stuffed up today, and I don't know why. Yeah, so the plan for today is to work a little bit on Torii and Squishy, maybe? I don't know. We'll figure it out. So we can just jump right on into it. Oh, hi, Luke. It's been a minute. Haven't seen you around in a while. Oh, there we go. So far where we got to last time was with the ASIC stuff. So what I might need to do is rebase, because I did a bunch of updates from Amaranth and I pulled those bug fixes in. So I also did some other miscellaneous fixes. So we'll need to probably rebase the ASIC branch on that. So, hi. So then now that we have those changes rebased, where we got to last time with the ASIC platform was that we ran into the issue where we need to specify the ports from the design. So our little ASIC example here, our little ALU ASIC example, while we do have the ports, and we do pass those to build, with the example flow stuff, currently the open lane flow, we don't actually extract those ports. Because we're not overloading these calls. So to kind of show what I'm talking about. Open lane. So with build, we're just passing on these things. We're not actually doing anything with the ports. So what we need to do is kind of shoehorn in the port extraction from... Oh god, that means I have to find the one I was poking at before. One second while I sift through a bazillion and a half tabs. Maybe it's here? It's somewhere. It's on this desktop. It's gotta be. Yeah. Hi, Sludge. But the point is, we need to extract the things from the stuff and do the things. Maybe it was here. No, this is all just the open lane stuff. I guess I have to go find that again. Grumbles. Why did I close that? You ever close something trying to organize and you're like, oh, why did I close that? Because now I have to find it again. Yeah, feeling that right now. Ba-da. Yeah. Sorry, I'm just digging through tabs trying to find a thing. Okay, okay, okay. Oh! Hi! Hi, hi! Thank you for following. Wayward... Wayward Trad. Wayward Trad. Yeah. Also, hi, hi! A13 Tech? Oh no. Okay. So what we need to do is I need to find the thing. So we need to extract the ports in order to properly add them to the thingy thing. I know I'm making loads of sense, but where we got to last time was here. I'll just run the ALU build again just so I can show you. So it's going pretty good. We're getting good, and then we hit initial floor planning stage, and because we don't have any of the IO described or any of the ports for our module, we get slapped in the face with it's saying that it can't do any IO placement. Well, rather, it can't do any IO placement, but instead of failing gracefully, it explodes because, well, yeah. Because, well, yeah. Right. Right. So in build, what we need to do is shim prepare, right? And this should be templated platform prepare. I don't know. Toolchain prepare. Right. That's the build plan. So I am not quite sure where we need to go, because what we need to do is we need to modify this. I think I am not remembering what we needed to do. Convert fragment. Right. Prepare. Propagate domains. Right. I did this before. I'm trying to remember how exactly it was hooked up. Because we do pass in the pins. But they don't get added. So. Uh, mm-hmm. Right. I think, yeah, what we need to do here is override prepare. Right. Okay. Sorry, this is a lot of thinking and my brain is not booted up properly at the moment. So in prepare, we do a fragment get. We assert self is not prepared. And then we assert that prepare is true. This is problematic because we kind of need to shim a thing. Oh, right, I know where the thing was. I am a dumbass. It still doesn't solve the problem, but... it was here. So what we need to do... is... see, propagate ports should do the thing. Your ports. Generator signal, yada yada yada, right? So if we're passing... so... okay. Okay. Sorry, I'm thinking through this as I'm talking about it. So in build, we pass through ports, right? That's fine. We don't touch it. Super build, ports gets passed through in here. Right? Self-prepare, elaboratable, yada yada yada. Right, then we go in here. Prepare. Wah. So we don't actually propagate the ports into the thing. Excuse me. So somehow we need to stuff ports into this. Which, how would we do? So let's propagate ports, self-iter ports. Self-iter ports, we need self-ports. So what we need to do is append ports, right? which this doesn't really have a way of, the resource manager class doesn't really have a way of doing. Right? So we can't actually append ports without getting a little tricky. Add resource. More resources. Resources. Yada yada yada. Solve. Yada yada yada. Ports append. Then the ports are a resource pin, port, and a tuple. Ba -ba -da -ba -ba. Trying to think about how to best go about this without having to duplicate a lot of garbage. I guess currently we can... Well, we're gonna have to patch this anyway. Oh, get fucked. I'm gonna have to... Come on. Oh. There we go. That is a bot. Yeah. Hi. I don't have the moderator interface up right immediately, so I had to map the thing. Okay. Yeah. It looks like they've started following and then waiting a while before spamming. Yeah. Right, what was I doing? Right. Templated platform. Hierarchy, separator, join, map name. Name map, okay. Okay. Last I checked, that wasn't in there. Nobody likes scam bots, correct? So the way I was doing it previously, propagate domains, platform equals self, domain lower, fragment. Girls are good. Yes, I agree. Ports. Inner ports. Yes, yes, agreed. I wonder how bad things will break if I just patch it in here, right? Like, if I go... Additional... How the fuck do you spell additional? Ba-ba-da-ba-ba. Right, we'll just do A ports equals required dot get ports, otherwise an empty list. And then maybe that might do what we're looking for. Use a higher density or refloor plan with a larger core area. That's progress. That is progress. So up the density or refloor plan with a light. What is my density? I think that was the appropriate one to change. But it didn't bail out because we didn't have any ports. Detailed placement failed. What? Was it PL target density we wanted? It would be nice if we got any more, you know. Anything more useful than that. Right, alright. Let's go hunting, I suppose. Nope. I think this is the latest one. Placements. There's nothing in placement. Uh, This is making me grumpy. Well, let's look at these outputs. Okay. Like, this should be pretty straightforward. Right, we have 4 input outputs. Why is it complaining? I just try to dump the density down. I have a feeling that the change to platform integrating the ports is not doing what we want to. Yeah. Yeah, so it's saying, hey, here's your target density. Try that. So if we try target density of 6, right? Sorry, I know this is terribly boring. Yeah. Flow failed. Why? Yeah. Why? I don't understand. Yeah. Let me... Or I can just do... Yeah. Let me just see what A ports is. Okay, yeah. So that's fine. Ha ha ha. Preset synchronizer, that should be fine. Uh, I don't know what actually is going wrong, which is slightly aggravating. Alright, let's delete all this. What do you mean I could not delete? What? Why not? ls build from about 18. Why is that owned by root? That's not correct. Alright. Alright. So we're starting clean. Oh, where did it go? Build. Repair. Alright, I want to get rid of this. Right. Run logs placement resizer. Oh, that wasn't what I wanted. Yes, that's sudo asking for a security key. Okay, Mary, have fun. Why? Yeah, why did placement fail? Who knows? Maybe that'll fix it. Just play with numbers until it works, right? That's how you program. That's how you make ASICs. Yeah, I thought so. Suggest target density. Munch. Maybe it's my Halo. Try again, I guess. I really don't have a good way of figuring out what is going wrong right now. Oh, I think it's gotten farther. I think I accidentally whittled it until it worked. Oops. Okay, that works, I guess. We'll see what it spits out. Running multi-corner static timing analysis. Yes, you boop it until it works. Oh, it's streaming a GDSI. Oh, writing Verilog, running magic. I don't care if DRC fails at this point. Flow complete! That means we made an ASIC. That's a success. That is a successful ASIC. Well, it's laying out an actual circuit that you fab into silicon. It's going to be a lot of steps. Hey, look at that! It's our ALU! Well, technically, that's our ALU. It's very hard to see. Let me turn a few things off. Yeah, there's our ALU. Isn't it cute? It is small. It is tiny. And then if I go tools, 2.5D view. There's our little core. Isn't it adorable? And then that was made with this code. It turned this code into that. Ready, ship it. Can I hop on MPW 8? Or 9, I guess. I think 8 already moved. But yeah, this is exciting. I think these are all like caps and stuff. We can actually see the individual cells. So if we turn off a lot of these fill cells, don't mind me, I'm just trying to figure out what these big thick ass cells are. HDD cap 12? There. Ah! That's a lot better of a view. Minus all that text. I have no idea what layer the text's on. Come on, what layer is the text? Label. Yeah. But anyway. Got an ASIC. Tiny little ASIC friend. Yeah, that's exciting. Let's try and line it up a little better. Yeah. And then these big rails up here are power and ground. Yeah. I'm sorry. But yeah, that's exciting. If I can bump the core utilization up a little bit. Yeah, okay. So it looks like the core utilization and the density were conflicting and causing problems, so it wasn't able to properly size the thing. Also, thank you for the pats, Dark Witch Claire. I forgot to say thank you. Pats, pats, pats. But yeah, okay. What if I just get rid of that? We'll abort that, that's fine. Okay. That looks to be cooperating as well. Yay! This is kind of a hacky way to do it, though. I don't know how I feel about this. Can I actually? Is it possible to propagate ports more than once? So instead of doing this here, right? What I do is I cut that out. And in here, do def toolchain prepare. And that's fine. But what I will do is this. Get ports. No. No, thank you. None. Excuse me. And then if a ports is not none, we will propagate the additional ports. And then I should. Where's build plan even located? Where's build plan? Build plan isn't run. Uh-oh. Oh, no, I wanted run. And then fragments, which is from HDL. I don't know specifically where it was. IR. That's correct. Okay. So, in theory, this will also propagate our ports. So if we try that again, the ports should propagate again. Okay. It looks like our ports propagated, which is good. Doop-a-doop-a-doo. Propagate is a hard word to spell. Results. Final. Yes. And this one was... that's much worse. The density is kind of bad. No, that's fine. That's perfectly fine, Mary. It's just I didn't specify the density, so the density is a lot more spread out. It's also kind of big. That's a... It's like 80 microns. Yeah, it's like 80 microns. That's kind of large. No, you're fine, Mary. You're fine. But yay, that's a successful thing. Oh, oops. That needs to be there. Yeah. Yeah, you're right, Sludge. That's fine. Actually, let me do this. Yeah, yeah. Yeah. Okay. Oakley dokley. But yeah, that's exciting. That is very exciting. Uh, yeah. Excuse me. I'm sleepy. Which is fair, I guess. I was awake at like 1 in the morning when I woke up. Okay. So we got that done. Still not entirely final. But it's something. Okay. Yeah, thank you for pats. Patto patto. Oh gosh, excuse me. Uh... Hmm. I have to go probably bug Matt Venn about setting up open lane flows in a GitHub action so I can implement a test suite for this. Oh my god, I'm so sorry. I'm so yawny. I'm too sleepy for my own good. Right, that's fine. It's noon, how am I this tired? I woke up at like 1 a.m. Also, I've not had any stims for like 4 days. I ran out of Monster 4 days ago. Okay. Uh, Yeah, yeah. See, I'm just the sleepy little girl. Just sleepy. Uh... Yeah. Yeah. Oh, thank you for following. Get demon in the closet. Local. Stretch. Okay. Oh, crunch goes the back. Oh, God, that felt good. That last bit was my neck. Don't worry, I'm fine. The setup's not too bad, actually. As part of the Torii ASIC stuff, I want to write a basic tutorial and maybe make a tutorial video on getting set up with it. Because it's not too bad. It actually is not that bad, I've found. Docker. No, what am I doing? What am I doing? Oh, sorry about that. Yeah, I have that to try to minimize spam bots, but they still kind of get through. Also, thank you. Thank you for the message, and thank you for hoping you have a nice stream. I will. Uh That'll do for that for now. I guess. What can we do? What can we do? Oh, hi, Annie. A little Annie girl has come to say hello. Did you have a good nap? Yeah. Hi. Come on up. Hop, hop. Boink. Yeah, hi, little girl. Sorry, Annie has mandated that it is time for a break. I can't type with a cat in my way. Hi, little girl. Yeah. Did you have a good nap? Yeah. Oh, you want pets? You want squitches? Yeah. Oh, yeah, you're liking that, huh? Such a good little girl. Such a good little girl. Yeah. Please don't knock over my water. Okay, it's granted it's an empty cup, but please don't knock it over. Hi. Yeah? Yeah. Sorry, mandated cat break. You gonna look out the window now? Okay. Alright. So now that we had the mandated Annie break, gotta figure out why it's doing that. I don't know if there's any way for Docker for us to ensure that the volume mount is set to us. That's what I thought that would do. What does that do? Okay. Wow. No, it says that's fine. Username or UID format is UID:group ID. That's fine. I can make sure that that's what it's actually generating. Ah, yeah, that'd be it. Oh, did you hear that adorable little sneeze? Hi! Ah, that was a cute sneeze. Okay, I have a feeling that it's partially due to my invocation here. Let's just do this. Well, that caused problems. That is not the one I want. Ah, yes. Yes, yes, of course. What I might just do then... is that? Pop, 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 pop. You can set variables on a new line. I've done it. It's just when rendering the command template, it does some funky stuff. Da, 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 da. Yay. Yeah, okay, these are owned correctly now. Yeah, okay, I was just stupid. I fixed it. Yeah, okay. No, no, it's okay. It's okay. This is comfy. This is a comfy stream. It's okay. My brain isn't working either. I get it. Pat, pat, pat. No brain, only girls. Correct. Again, yep. Girls. Alright, well, that means we are successfully generating combinatorial circuits into ASICs now. Which is good. That's exciting. But yeah, okay, so that's good. I should commit that fix. Yeah. Stage selected lines. Ta-da. Okay. Excuse me. Oh my god. So sleepy. Uh. Okay. Now what do we work on? Doopity doop bop. Ba da ba ba. Yeah, haha. Oh, hi, Annie. Annie has come to say hello again. Hi. Hi. Are you just a little girl? Are you just a little baby? Just a little baby? Yeah. Oh, how are you so soft? Why are you so soft? Soft. Just a soft little baby. Yeah. Oh. I wish I had a cat cam so I could show you, but she is flopped over on her side now, laying against me with my hand on her tummy. Oh, baby. Hi! Yes, FPGAs. Well, at the moment I'm taking a break because I have a cat wanting my attention. She's getting belly rubs. But we're working on an HDL. In this case, we're working for ASICs. So we have a Python-based HDL, which then invokes OpenLane, which then generates an ASIC. Yeah. So we've got a thing that takes this basic ALU code, right? Pretty simple and self-explanatory ALU code. And then what we do... Ow! Why are you biting me? I'm trying to type, and you are just in the way. Don't bite me. And then we basically run it. And what this will do is take that code and turn it into a GDS, which is basically the layout files for an ASIC, or an application-specific integrated circuit, which is, you know, what they turn... It's microchips and stuff, like actual silicon. So that code was turned into this. FPGAs aren't that bad. I've got way more than just 3. I've got, oh gosh, I've got an Artix, a Zinc, Spartan, 2 ECP5s. I've got a lot of boards. Yeah, I've got a Z7. Yeah, the 3D view. Oh, this is something you can do with ASICs too. You can turn them into blend files. Whoop. Yeah, no, that's fine. So this is an ASIC that I took and imported into Blender. And then I added a bunch of materials. Set up the camera. And then we render it. And there's the image. And that's the render of the ASIC. It is very pretty. I'm using it as my background, actually, for VTuber stuff. What? It's only 15. And then I have 3 monitors. It's not that bad. I don't have a problem. I don't know what you're talking about. But yeah, so what you can do is you can turn the ASIC... Oh, hi! Hi, Amy! But yeah, you turn the ASIC into a blend file. Oh, hi! Hi, Carrie! Speaking of Blender, what were you up to? Oh, thank you for following, Pretty Fist. Snake Raid! Snake Raid! Yeah! Shout out to Expired Popsicle. They're cool. They're also a member of Null Putter Live. I was just showing off my Blender workspace for the ASIC stuff. Isn't it pretty? It's a lot. Oh gosh, so many new follows. Thank you, everybody. It's a lot less cool than what you're capable of, because I didn't really do any of this, except the material work, but yeah. This was a side tangent, too. Oh, I'm chugging. Yeah. But I was just showing off what you can do now that we have the ASIC flow completed. Because that was originally a... If K-Layout decides to open. Doop-a-doop-a-doo. That was originally one of these with this, which is a LUT 4. Which has a similar 2.5D view. Anyway, hi, Kiri, what were you up to? Thank you for the raid again. It's very much appreciated. Oh, Annie! Annie has woken up from her nap. And she has decided she's in a playful mood and pawing at my butt. Doing Blender stuff? Yeah. You're the Blender snake. I was just stumped for what to do at this point now that we got the basic ASIC support working. We could try and stuff another example into the ASIC realm. Blend the snake and the kitty. Yeah. Yeah, I'm actually unsure of what to do next. As bad as that sounds. What to do. Time to make a CPU? No, I have got many things on my list. Making a CPU is sadly not one of them. Not yet, anyway. You're okay, Mary. It's all good. I mean, so making a CPU, Uriharu. Yeah, but that involves having to learn Rust more. You're fine, Mary, you're fine. I could just move on to squishy. Could work on some squishy stuff. Could do squishy hardware. Thinking. Squish, squimsh, squimshy. I could show off squishy and talk about it a little bit, I guess. We can do that. We are now on the squishy workspace. So, could you guess hardware needs a little bit of work. I don't remember where I was. I was somewhere. I have a to-do list for the hardware. I don't remember where I put it. There it is. I found it. Oh, this is squishy. Well, okay, more correctly, this is Squishy Revision 2, which is what comes after Squishy Revision 1. If I can open another aki-nyan. File. Five reports, Rev 1 Squishy. We'll do Rev 1 Squishy. So, Squishy is a SCSI interface device, basically, right? So what it does is you have a SCSI device on one end, and then a host device on the other end. Wah wah, nya nya. And then it lets essentially a computer pretend to be a SCSI device, or a SCSI device pretend to be a computer, whatever, right? It's basically a generic interface adapter. So it's all based around an FPGA. It's all based around the FPGA. In this case, it's an ICE40 HX8K. No, so it's flexible. So this is just, in this case, it's just a physical hardware interface to SCSI 1 HVD. But it can be anything, basically. So all of the USB, all the SCSI, all of the logic for the device is dynamically programmed in the HDL, which is then built into a bit stream, which is then flashed on the device. So you can you can pretend to be one SCSI device, you can pretend to be 4 SCSI devices, you can be a target, you can be an initiator, you can be a passive occupant on the bus sniffing the traffic, you can do weird cursed things with SCSI bus extensions via LUN addresses, you could do SCSI RDMA, yeah, basically anything you want to do with SCSI, you can do it, right? So that's Rev 1, which was SCSI 1 HVD only, which is, you know, kind of limiting, but it was limiting for a good reason, because, let me get the stuff. Let me get the thing. I did a talk about it, right? Some types of SCSI devices are things like hard drives, printers, scanners, cameras, tape drives, worm drives, processors, etc. Yeah, of course. So there's the talk I did on SCSI, or on Squishy, right? And I'll just pull up the slides for a second. So the original goal was to talk to this, which is a 9-track tape drive, right? Not that kind of worm sludge. Write once, read many. But yeah, Squishy was originally designed to talk to this, which is an IBM 9-track magnetic tape drive. And it talks SCSI HVD, so there was a whole thing. I really recommend you watch the talk, but here's the hardware. It's assembled, it's real. Right? So this is Squishy, and then there's whatever you want to attach to on the SCSI bus. And it's tiny, and there's tapes. Yes, it's purple, and I have a lot of tapes. And there's also a very cute mascot for the project. And I have many of them. Anyway. So, Squishy Rev 1 was designed to talk to SCSI 1 HVD only, because it was dedicated to talk to that particular tape drive, which happened to be SCSI 1 HVD. However, Revision 2 is going to be a lot more extensible. It's using a much bigger FPGA. It's going to be upgrading from USB 2 to USB 3. That would be a good name for the project, but yeah, optimization sucks. And yeah, Luke, in this case, it's tape for data, not tape for audio. The problem is, so you'd probably be well aware of this problem, Luke, is sticky shed for tape, right? How the magnetic material flakes off the backing of the tape. That's a problem, especially in data tapes, because they're a lot older. And the issue is, with 9-track tapes, the coercivity is much lower. It's below audio tape. Right? So the problem is, I can't just use half-inch audio tape for 9-track tape, because the coercivity is too high, which means the drive can't write to it because it can't exceed the hysteresis of the magnetic material. So I'm just grumbles. And I emailed Graham Magnetics, which was the last manufacturer of reel-to-reel magnetic 9-track tape in the United States. I emailed them ages ago. I haven't heard back. I need to email them again. I'm just kind of exasperated. Yeah, tape rot. It's bad. Ow, Annie! Ow, why are you... Sorry, the cat is being very bitey all of a sudden. But yeah, anyway, as I was saying. Oh, yeah, definitely back those up. Because once they're gone, they're gone. Yes, the Antifa logo is part of the design. But, so this is revision 2 of Squishy, right? So it's going to be SCSI 1, 2, 3, HVD, LVD, and single-ended, all in one, which is where this space is reserved for. It has a much larger and faster FPGA, so that way I can properly hit things like the, it was like 100, was it like 80 megahertz DDR? What the fastest version of SCSI. I should be able to talk the fastest version of SCSI with this. And as such, I am adding USB-C 3.0, so I've got all of the routing for the high-speed lines here. I'm also adding onboard storage, so, you know, so you can make it act like a drive emulator, but that's not its only goal. No, double data rate. So DDR is when you have a single so normally, yes. Normally what you do is you have a thing. Oh, hi! Hi. Yeah, so normally with, yeah, okay, no, it's fine. I'm just not sure. So around here, it's okay not to know things and ask questions, even if you think they're silly or stupid. Like, even if you think it's basic and you should know better, it's okay to ask that question, because the worst, I hate people who say, well, that's basic knowledge, you should know it. Oh, shouldn't you already know that? That's not necessarily true. So I try to be very open about people not knowing things. And I don't know a lot of things either. So I might just be a complete dumbass and completely miss something or not understand something. But I want people to feel comfortable here enough to ask questions that, even if they think are stupid, are important to them, right? Because not everyone has the same experiences or gets the same level of education or anything like that. So it's important to take this very kindly and not accost someone for not knowing something. That's the worst. When someone is mean and says, you should know better, why don't you know this? That's the worst. That is just the absolute worst. So I try to take every question with a grain of salt seriously, that person might not know that, and even for the benefit, if the person does, there might be other people watching that don't know that and are too afraid to ask. And to those people I want to say, please ask away, but in either case, you know. Yes, you can have hugs, Sludge. Also, I apologize. It appears someone is starting their car outside. And yeah, so gatekeeping is very, very bad, and I very much dislike it. I also dislike the whole elitism about things. It's no good. Anyway. Anyway. Ha! No, I didn't. I did not go to university for electrical engineering or anything like that. What was I saying? Sorry, page fault. Right, Squishy. So, Squishy Rev 2 has this pluggable architecture with a very high density pin connector up here where you plug front ends onto. So you can adapt these to be various interfaces for SCSI. And then I want to build a universal transceiver down here, but that's very unlikely, so I might have to shorten the board and then put the transceiver on the other board. I don't know how I feel about that. Kind of mixed signals. Annie. Yeah, you know you're not supposed to be over there. Sorry, Annie's getting into trouble. Annie, come back. Yeah, okay. You're fine if you lay down there. All right. Sorry, cats. But yeah, so that's the goal with Squishy anyway. And it's based on a very flexible software setup where it's all done in the Python Gateware DSL that I was working on. Right? So we have applets, and then an applet has base class, and it has an elaboratable, and the elaboratable is what implements the logic for the device. So in the action with the applet, what you do is you can select a thing. I can actually show this right now. So if I plug in a Squishy, I now have a Squishy plugged in. Ah, come on. So you can see Squishy showed up here. And then if we go to show the help, and then if we do verbose, verbose, and then we want probably applet, or no, let's do provision. Oh, I didn't spell provision right because I am bad at spelling. So what this does is this generates new gateware for Squishy, and then it will, in this case it won't upload it to the device, but if you didn't pass the build only, it will not upload it. It will upload it to the device. And there's a bunch of DFU stuff in here, which I will show off once this is done building the gateware package. It takes a minute. But this is building the gateware for the device live, so. And this is using 100% open tools. The entire tool chain is 100% open source. So yeah, so that generates a unified bin. And then if we do DFU util list, you can see we have a squishy DFU here. So then if we go... Kinda. So it takes the Python, in this case, the bootloader. So I'll actually show off that. I can show off that code pretty easily. Boop, boop. So here's the Rev1 bootloader. Right? So it's an elaboratable, and this is the code that implements the bootloader. Right? This is the entire logic of the bootloader. Including USB. We also do full speed USB on the FPGA. But this implements the bootloader and everything. And then what we do is in provision, we essentially take the device that we're targeting, we call build, and we pass in the elaboratable and all of the options. And what that does is that takes the HDL that we wrote and writes it out to RTL-IL in a Yosis script, which is then synthesized into Verilog for debug, but the RTL-IL is directly synthesized and elaborated into the JSON netlist format, which is then fed into next PNR. So if I go cd So as you can see here, there's a bunch of stuff. So if I bat build squishy bootloader, this is essentially everything it does. And you can see kinda, it essentially runs a Yosis script. And so, oops. That's the Yosis script. And then the squishy bootloader IL. This is the RTL-IL that it emitted. So this is the entirety of the core that it is synthesized. And then that's just fed out into the JSON. Done the things. So if I actually manually do this, so what I can do here is cat this. I can load up the next PNR GUI. And then what we can do is pack the design, place the design, and then we can route the design. And as you see, it's a very compact design. This is the entirety of that bootloader mapped out into an FPGA. In this case, the HX8K. So it's doing a little more than compiling Verilog. But essentially there is no Verilog step at all, right? It completely skips the Verilog and goes right to RTL-IL. If that makes any sense. Excuse me. I am sleepy beepy. It's not wasted, it's just not used. I mean, it's empty, right? And with FPGAs, you can only program the whole device at once unless it supports something called partial reconfiguration, which the ICE40HXK doesn't. But the empty space, I guess you could consider it wasted, it's just we're not using the whole device. And honestly, it's better if you don't use the whole device, because then you get more freedom with place and route and you can keep your timings up. Yeah, so I technically work at Yosis HQ. Semi-doxing myself there, I guess. But it's not a secret where I work. Yeah. But, so working on the Yosis tools and using the Yosis tools is just kind of what I do. Yeah. But yeah, there's no Verilog really in here. It's all the DSL into RTL-IL, which is then stuffed into Yosis and emitted as a netlist itself. Directly to place and route. Yeah. I honestly don't like Verilog. It's icky. Anyway, close that. I am probably gonna wrap up. That is absolutely absurd, Gyrus. That is absurd. Mary, a net list is basically just a description of wires that connect to each other and other cells. It is a list of nets. And a net is just a list of things that are all connected together. Yeah. Right, well, I am just about out of steam, and we've been going for almost 2 hours. Yes, it's to help catch the FPGA ghosts. Let's see, who can we raid? Who can we raid? Da-da-da-da-da. Yeah, pets, thank you. Yeah, no, thank you all. Trying to figure out someone to raid. It looks like Gyros is streaming and chatting in this stream at the same time. Now that sounds like shenanigans. Ba-da-ba-da-ba-da. Yeah, okay. Let's do this. So yeah, thank you all for stopping by. It has been a pleasure. I appreciate everyone who came and hung out. It was nice. So yeah, let's switch on over and have a good one. Bye bye.